Middle. So segments that connect the middles. So in a triangle, how many sides do you have? 3, which means how many midpoints could you have? 3. So how many mid-segments do you think you could have? 3. Really tough here. Mid-segments are the segments that connect midpoints. Okay? Ladies and gentlemen. Mid-segments of a triangle connect the midpoints. Okay? So, like I said earlier, inside of a triangle there's always 3 midpoints, which means there are going to be 3 mid-segments. Okay? They have a couple of properties, and they're really, really easy. What's that, bud?
What triangle is it?
Now, here's what happens then. The mid-segment, you should be sorry. If you didn't make mistakes, I mean, so the mid-segments have a couple of properties. The mid-segment equals half the side it doesn't touch. And the mid-segment is parallel to that side. So the mid-segment is always going to be equal to half the side it doesn't touch. And it's also parallel to that side. So as you get into these things, you're going to see how unbelievably easy this is going to become. So triangle has 3 midpoints. Mid-segments connect them. That means this mid-segment doesn't touch this bottom part, does it? This mid-segment doesn't touch this part, and so on and so on. So, I know it's going to be really, 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 really difficult. If this whole segment here, this side, is 12, how much is this portion?
6.
6.
Actually, for now.
Okay? It's equal to half the side it doesn't touch. Alright?
I wish everything were
if this mid segment is 8,
16.
how much is the side it doesn't touch?
16.
Okay? Alright? Which then, if you start to look at it, if this is a midpoint, and the whole thing is 12, what is each individual part? If this whole segment is 12, that's the midpoint, how much is each of these sides? 6s, okay? Which means that this has to be equal there. If that whole thing was 16, that means these parts are 8s, which means this is the same thing there. And then for last example here, let's say that this part here was 9. How much is the mid-segment? 4.5. Good. I know it can get a little crazy here, but what happens here is notice that when you cut a segment into half, notice how I put those 2 tick marks, or put the tick mark on the either side here. If I look at this side here, I had the tick mark 1 and 1. Those both measured 6. So did that. That's why I got 1 tick mark. So what happens is you wind up with, you were just saying this earlier, Christian, you got 4 triangles. All 4 of those triangles are congruent because of side. Okay. Again, that's not anything we have to worry about proving or working through or anything like that. But it's one of those ideas that This is why all of this stuff kind of works. Okay. Again, mid-segments are super easy to work with. Mid-segment equals half of the side not touched. Yep, and the mid-segment, I don't know why I forgot to put the I in here, is always parallel to the side not touched.
Guess how we have to make more triangles?
What's that?
We make more triangles?
Yes, sir. You can make more triangles, that's good, yeah, but if this one here has midpoints in here,
That's a lot though. The other would be 3.
You could make another one? How many of those could you make?
Whoa!
Wouldn't it be infinite?
it would be infinite.
That's crazy.
This is, I believe this is called Pascal's triangle.
That's like the head.
Is that right?
Yeah.
I think. And then each one of these.
It's just crazy.
You can,
It's like, that's like this thing.
yeah. And there's I know that in my honors algebra 2 class, there's something that deals with, it's called binomial expansion. And binomial expansion deals with how you can build the number of triangles you can get within this thing, and it's all
That's what I'm saying. It's like,
yeah, same basic idea. Yep. Yeah, so yeah, that's a good, you could have infinitely smaller, you guys know what I mean by infinitely smaller? When we're talking about the idea of infinite, it means there's always something smaller than something else. All right? It's like the whole idea is, I'm not touching you, I'm not touching you, I'm not touching you. That would get annoying, wouldn't it? Really? I wasn't going to, but you're like, ouch. Okay. Again, no big deal with this one. We did that one, we did this one. All right, so like I said, if in the diagram, let's see if we can figure this out. This is gonna be really tough. I'm trying to build it up, make it sound like it's really tough, and then you guys all go, man, this is super easy. So ST and TU are mid-segments. It tells you this. These types of problems will tell you that, or you'll see it via tick marks like we were doing a minute ago, how the tick marks will match up. So if TU is a mid-segment, what side doesn't it touch?
SPQ.
SPQ. What is SPQ? That's on the other side, man. Watch your letters. It doesn't touch side QP, right? The 10 feet. So what does TU have to equal? 5. Okay. Welcome back to regular math, ladies and gentlemen. I'm hoping you like the stay. All right. Very good. And then PR would have to be 16. Everybody see that? You double it going out, cut it in half coming in. What about which one? I'm sorry? What would QS be?
QS?
Yeah. Right. Very good. Yep.
PS would be also.
Very good. Very good.
PR would be, or U would be.
Yes. Now, we haven't gotten this far yet, but eventually you could figure out those other side lengths once we start to figure out how to do some of the angles. But that's second semester, John. Okay.
Wait a minute. That seems like a lot.
Well, go back to, let's see. The example we had a second ago was what? We had triangles with 4.5, 8, and 6. Okay. So don't write this down. Oh, sorry. You said 8, so I was writing. Now, if I say this is A, B, and C, which one of those angles has to be the greatest, the biggest? What angle? What angle has to be the largest? B. Why does angle B have to be the largest? It's got the biggest side across from it. Remember that? Okay. So there's all these trigonometry rules that we can do to figure out the angle measures that are in there. It's something called law of cosines, and obviously it's nothing that you have to do now. But it's basically 8 squared will equal 4.5 squared plus 6 squared minus 2 times 4.5 times 6 times the cosine of angle B. It winds up being a whole bunch of buttons you have to press in the calculator to be able to figure out what the angle is. And you can do that, it's just not something we're doing yet. Okay? Yes, sir. I told you don't worry about this. If you had your earphones out, you would have heard me. Anyway, back to this. Does it matter if there are decimals for mid-segments? No, not at all. Not at all. So just in talking here, don't even bother writing this out. What would you do to that 26.5 to figure out what MN is? Divided by 2. Multiplied by 2. Okay. So you just double it. So you would double it going out. This should be something pretty easy to do. If you double 26, what do you get? 52, and then you add one more, and you would get 53. Okay. So for those of you guys that have been slacking off and not bringing calculators, bring your calculator.
Well, I stay with my calculator.
Okay. We did these. So I don't want to do one's too easy. What happens with algebra? Oh no. If this is 16, what's that? 8. Whew, that was tough. If this is 4, what's that?
4.
MP is a mid-segment, so that means P is the midpoint, so that has to be, okay? All right, if that's a mid-segment, how much is that?
9.
9, okay. Let's talk about the algebra. This is where I want to spend a little bit more time. Okay. As we go through stuff like this, I'll give you guys a second to draw this up here. It says triangle X, let me just do this real quick. Sorry.
But you know, I'm South Home. That's how I think of it. Nigga, why I'm looking right now?
Hey, so back to here. I was just trying to blow this one up a little bit more so you can see it. It tells us in the instructions that I just kind of cut off here that points, gentlemen, it says points U, V, and W are midpoints. Okay? If those three are the midpoints and there are segments drawn to the midpoints, that makes each of those internal segments what we call mid-segments. That gives you UV, VW, and UW are all mid-segments. Now, in the problem, it gives you UW is 4x minus 1. And then it says YZ is 5x plus 4. Now, which of those two segments is the mid-segment? UW. Good. So that means that the mid-segment is half the side it doesn't touch. Or what's another way that I can write that? Louder. Yeah. Another way that you can write this is if you double the mid-segment, it equals the side not touched. If you notice on some of those problems we were just doing rather quickly in our heads, where we had that 4.5 and it was the mid-segment, and we had to double it real quick to get the side it wasn't touching, you were doing that right away without realizing that that's exactly what you were doing. Right? The process by which you're doing this is just inverse operations of multiplying by half or dividing by 2 versus multiplying by 2. So when I get to a situation like this, I just have to identify which of the two is the mid-segment. And then I know that I have to double it to equal the other side. So if I double my mid-segment, 2 times the 4x minus 1, it has to equal the 5x plus 4. Does that make sense?
Yeah.
It's just noticing which of the parts you're working with. Once you get that far, the math is easy. I will tell you one thing, a spot that you guys tend to mess up. When you distribute, you forget to set it to the second term. So please take a second and draw your arrows as you're doing it so you don't make that silly mistake. You wind up with 8x minus 2. Because there's 4x minus 1.
Oh, I put a plus for reason.
Okay. Oh, that actually, stuff like that, Christian, some stuff like that did happen on the test yesterday, where a couple of you guys wrote down, I think the problem might have been the isosceles one, where it was like 3x, I think one of the parts was 3x minus 1, so you guys wrote down 3x plus 1. You still got a clean-ish number, but you just wrote down the wrong sign as you did it. you know your math right, you just wrote down the wrong thing. Those are things that I don't mark you wrong for, I just yell at you.
What?
Okay, so now you're back to variables on both sides of the equation. Always pick on the little guy. So you subtract the 5x, add the 2 going back. And I saw you already had the answer. What was the question? 2. Good. Now, the value of x is 2, but the question will ask you to do something with it. In this case, it asks us to figure out what UW was. So this is tough now. 4 times 2, subtract 1. Okay, so that means that UW is 7. UV, YV should be 7, but we should make sure we did our math right. So if we did our math right, what should this big segment have to equal? Should be 14. So this is tough again. 5 times 2, add 4. Did we screw up? And that's the idea. Welcome back to normal algebra and math with geometry.
Thank you.
All right, as we go through those. All right. Excuse me, sir. Usually on a test, this is a good question, guys. Usually on a test quizzes and stuff like this, but I have problems like that, I'll have a spot off to the side where it says UW equals blank, and you just fill in your answer. Yeah. It depends on the problem. Okay. Just like I said earlier, because you had your earphones on. Probably not as well as you should be. Mid-segment, it has nothing to do with that. Is half the side it doesn't touch, which means if I double this, it equals the side not touched. It's another way of writing it. Okay. So let me actually give you this sheet that has some stuff. I printed out a sheet that has some examples. That way we don't have to continually redraw them, because I know the triangles can get a little messy. Thank you. I'm just passing this out. So let's take a look at some of these before we get to this. Nope. Just doing some examples. I just didn't want to continue having you guys draw out problems all over and over again. So on this front page, take 2 minutes and figure out 2, 4, and 6. Like I said, that should not take you more than 2 minutes. On the front page, take care of 2, 4, and 6, and we'll check our solutions here in a second. 2, 4, and 6. Then we'll switch to the algebra here.
I got you, man. I got you.
Well, what'd you get for DB? Okay.
Well,
What's the last one? What'd you get for number 2?
12. 12. I got 12. You got it. No, wait, look. So I have
It was just perfect. Like, what? you guys all get 12. I know it's, like I said, this isn't that bad. Guys, you guys 12? Now, did you get 4? for number 4?
Yes.
Hey, and did you get 7 for number 6?
Yes.
Now, let's switch over to the other side. Let's look at the algebra. Algebra is where I want to spend more time.
Why?
I don't know if that's more work, but I just want to make sure you guys understand this is where you guys are making mistakes.
You're right.
And it's just that silliness that I just want to make sure we don't worry too much about how it sets itself through. Okay?
Because everybody makes mistakes.
Yes, sir.
And it's okay to make a mistake. Thank you.
Yep. So, when we look at number 11, when you look at number 11, which of those two segments is the mid-segment? The x, I'm sorry, I can barely read that. X minus 2 or the x plus 3? The x minus 2. Now, that means the mid-segment is half the side not touched, or if I double it, it equals the side not touched, which is going to be the easier way to set it up. So in this case here, it would be easier to double the mid-segment. So when you write it out, you know it's going to be 2 times the x minus 2 is x plus 3.
7.
All right? So you use your properties off of all that. When you use your properties, you distribute. You've got our 2x subtract 4 is the x plus 3. Pick on the little guys, move stuff around. Subtract the x, add the 4. Hopefully you guys can do all this in one step by now. And you get 7. Now, yes, sir. Oh, sorry. Thank you. So as you go through that, you'll notice, I think in these problems it would just solve for x, but sometimes I might ask you to figure out a segment and whatnot. So take a couple minutes to finish those last 5. We'll check them here in a minute, okay? Yeah. It depends. Remember, it always depends upon the problem. Some problems you double it. Some problems take half of it.
Yeah.
Depends on how you set it up. Okay. What do you mean? No, you have to know which one's the mid segment. So that's kind of the idea. If you know which one's the mid segment, you're good to go. Okay. Yes, sir. Yeah. Ladies and gentlemen, come on. We are. What's up? Remember, this it's like this. Well, which side does it touch? Okay, so this side.
Well, look at the time.
That's why we wrote it like that. It's not very thinking. Nice. Not bad. Yours? What?
Can we get no. That's called.
Yeah, why not?
Parentheses.
You didn't have it back there. I don't know why, it was in your hand and it flew over here. Why are you sitting like that?
What are you doing?
Verify presence and save the watermark, bold, white, bold, white.
Just to make sure we're on the right page. Just to make sure we're on the right page on 12. Remember, every one of these is kind of the same. Usually the easiest thing to do is to double the mid-segment to equal the side it does not touch. Okay? When you do that, you have a 2x and a 28. Subtract the x, subtract the 28. Did you get negative 6? Is it okay to get negative values? Yes. Because the segment isn't negative, but the x value. Okay.
Oh my God.
Okay. Now, one of the things I was mentioning is that usually when you have algebra on both parts, you could double the mid-segment and kind of stick in that realm and not have to worry too much. So on 14, if you double your mid-segment, you wind up with the 4x minus 30 is 2x minus 6. Bring the 2x over, add the 30. I believe you get 2x is 24 and x is 12. Well, the other way you could have done that one, see how the side it doesn't touch, parts of it are even? You could do half of even numbers and not have to worry about decimals and stuff. So you could have done it that way too, and done the 2x minus 15 is half of 2x minus 6. Because what's half of 2? What's half of 6? So subtract 1, add 15. It works the same. It's just that I normally don't take half of the one side unless both numbers are even. So if you stick with the idea of doubling the mid-segment, equal the side it doesn't touch, you'll probably be okay. All right? You should probably be okay. Yes, sir. I haven't done that one. I want to jump to that one real quick to show you this is a different way of doing it. So on, let's see, on 13, if you did it right, you doubled the mid-segment. So 2x, 42, x plus 32. Did you get x is negative 10?
Yes.
Get negative 10 on that one?
Yeah.
All right. Yes. And then the last two, again, should not have been too tough. Double the mid-segment.
Would it be a time where we have to
Not the stuff that we're doing here at all. Eventually, in this chapter, we do you can do 2/3, 1/3 stuff, but it's really easy when you start to see it because we make it very very visual.
You could take one side and triple that and do all three. You know what I mean? You know what I mean? So like, it's an equilateral, right?
Yeah.
Okay. You take that equation from that minus 2, and then multiply by 3.
Oh, I see. You knew what the perimeter was? Yeah, I see what you're saying. Okay. I wasn't sure where you were going with that at first, so. Did you get 12 on this one? And then the last one, double the mid-segment.
Yes.
So let's see, 44, 2x, 32. Subtract. Did you get negative 12 this time? The sheets with the CUDA stuff like this, they tend to give you negative x values. And you guys saw that with angles all the time. They do it again with these things as well. What I made up for you for some homework problems here is a mixture. Yes, ma'am. I think it's just kind of stuff.
Oh, I'm making cranberry sauce today.
No one knows. I'm
What you guys want to eat it?
So I want to look at this one real quick. One of the things, guys, one of the things that we had not discussed yet is how do you work with the angles. So what I wanted to do is show you guys on an example of how this looks like when we deal with angles. So on this one, this is the problem that I kind of like to know. The numbering on this is, like I said, I just kind of piecemeal this together from a bunch of different examples. So if I'm looking at, it tells us X is the midpoint of UV and Y is the midpoint of UW. So on my diagram, enough. On my diagram, I'm going to do that right away. Okay. Now, they're telling you that angle UXY is 60. Now, XY is mid-segment, isn't it? What side doesn't it touch? BW. Good. That means that these two guys are parallel to one another. So here we have two parallel lines and a transversal. So what they're asking us to figure out is what is angle V? Well, isn't this angle here and this angle here, aren't they corresponding? So that would have to be 60. Does that make sense?
Yes, sir.
That's about as goofy as some of these angle things are really going to get. All right. Same idea. If that angle is 60, this will have to be 60. And then they say W is 45. Well, if that's 45, what does the angle up here have to be?
45.
Very good. Does that make sense, guys?
Yes, sir.
All right. Let's see. The rest of this should be really fast.
33, so it's
What's that? What's that? Bud?
It says X, XY equals 55 because.
What does that have to be? I can make this more difficult if you'd like. All right. Go ahead and knock this thing out, guys. You got some time here. I bet you get over halfway done. Just knock it out, okay? Yeah, you guys. All right. This is quick.
I get it.
Yep.
This is 13.
Yes, sir.
Why is it 15?
I'm fine, man. Yes, sir. What about 40? What kind of triangle is it? Okay, but if the base angle is 60, that means what are all the angles? Okay, there you go. Oh, these are